Lab 4 will walk you through how to do a design of experiment in iWars. In this design of experiment, we will look at a squad moving through McKenna Mount site at different levels of body armor protection, so 2 levels there, default and none. Different weapon systems by the enemy. They have an AK-47 in one, an M249 in another, and the time of day, day and night. And to do this, we're going to use the case matrix and brass, as well as our commander to do the DOE analysis. But first, let's build our scenario in iWars. So first thing I'm going to do is I'm going to add on my blue squad. So blue unit squad. I'm going to move them over here. I'm going to change their formation to being file formation. And then I'm going to click it so that they are facing down the street. The next thing I'm going to do is I'm going to add 2 red agents. I'm going to place them on the map over here. Next thing I'm going to do is I'm going to add a path through the McKenna Mount site that our blue agents will be moving down. Alright, so we're in pretty good shape. For our first scenario, we're going to assume that everybody's wearing armor, so let's just make sure. So default protection, they're wearing their armor, so they are good. We're also going to give the red agents AK-47s. So let's switch their weapons from M4s to AK-47s. And then we have to change their munitions to being 7.62. Let's give them 210 rounds of 7.62, and they should be good. Yeah. All right, let's do it for this agent as well. Select munition, select weapon AK-47. Selected munition, give them 210 rounds of 7.62, and they are good to go. Alright, so next thing we're going to do is go into Mission Builder and define our blue mission. I'm going to call this Mission 1 Blue Mission. And for our blue mission, our agents are simply going to move along path and formation. I'm going to set that path to be path 1. And I'm also going to add an engagement mission. So shoot, engagement, retarget, so that when they spot the red agents, they will shoot at them. Because in this first scenario that we're looking at, they are moving in armor, we're going to set their movement speed to be a little bit slower than the next scenario. So right now it's 2 meters per second. We're going to convert that over to being 2.5 miles per hour. And so that's the speed that they will be moving at. Alright, so next thing we have to do is we have to define our red mission. So let's call this red mission. And all that our red agents are going to do is engage. So save scenario. I'm going to make a folder called Lab4, and I'm going to call this Lab4 Armor. Alright. So let's close that and let's run and see if it all works. I'm going to speed it up. They're moving. Oh, engaging. And both of our red agents are dead, but we did see that both sides engaged each other and that our blue forces are moving through the mount site. So we're in pretty good shape. Our scenario ran perfectly. So now what I'm going to do is I'm going to edit this model and create a second version where the blue agents are not wearing armor. So I'm going to go File, Save As, Lab4, call it No Armor. And in this scenario, I'm now going to change their protection level from default protection to no armor. I'm going to repeat that for every one of my blue agents. Alright. So now all of my blue agents are not wearing armor. So what I can also do now is I can make it so that they move a little bit faster in this scenario, because in this scenario they're not carrying as much weight. And we remember from Pandolf's equation that as your weight decreases, the amount that you're carrying decreases, you can move at faster sustainable paces. So I'm going to go to move along path. I'm going to set their movement speed. It's 2.5 miles per hour, which is 1.118 meters per second. iWars automatically converted it over. I'm going to change that to 3.5 miles per hour. So file, save scenario. And I now have my second scenario. And I'm just going to run this as well. So we can see that they're moving a little bit faster. More than likely, if we run this a lot of times, there's going to be a kind of a trade-off there. They're not wearing armor, so they're more likely to be incapacitated if shot. However, they are moving faster through that kill zone. Now that we have our scenarios built, we're going to analyze them using brass. And I'm going to introduce you to something called the case matrix. So I'm going to start by closing iWars and loading brass. iWars brass tool, and OK. I'm going to create a new project. It's going to ask me where I want to save it. I'm going to go into my Lab4 folder, and I'm just going to call it Lab4 DOE. So the first thing I'm going to do is I'm going to create a task group. I'm going to call it Armored. And this will be the task group that's related to when the soldiers are wearing body armor. The next thing I'm going to do is I'm going to create a case matrix. A case matrix allows you to change certain parameters in the model and basically do a DOE analysis. So I'm going to create a new matrix file. It's going to ask me to save, sure. It's going to ask me where I want to save that. I'm just going to save in the default section. And so it has my, it generates this. Now we have to define it. So edit in case matrix tool. It's going to ask me for my base scenario. So I have to select, in this case, it's going to be Lab4 armor. And what I'm going to do is I'm going to add in two different things that we're changing around. The first factor is going to be the Red Force weapon. So I'm going to go to Agent Factor, Selected Weapon System. I'm only going to apply this to the Red Force. And I'm going to create two levels here. So in case 1, the weapons that they're carrying is the default that we gave them. AK-47 with 7.62, no mount. Case 2, we're going to give them a M240, so a machine gun. We can give them 7.62 again, and we're going to do no mount. The second factor that we're going to change is an environmental factor where we change the time of day. So I'm going to create two levels here. First one being late AM, and the second one being quarter moon night. So if we look over here to the right, we can see that there's 4 different combinations where we're varying the Red Force weapon along with the time of day, and you have two levels of each for a total of 4 possible combinations. So AK-47 during the day, AK-47 at night, 240 day, 240 night. Unfortunately, when you start looking at these different agent factors and whatnot, it doesn't give you the option to change armor in here. It's not built into the case matrix. And so that's the reason we had to do it on our own. So we can now save our case matrix file, close out. It's going to ask if we want to move out. We don't have to move our scenario. I'm going to set it to be 200, or run for 200 seconds and 2 replications. I'm going to create an output analysis. We call it armored analysis, sure. And unfortunately, we cannot edit our analysis file. So if we go to edit output analysis file, it's going to ask us to run the scenario first. So we can do that. Just click, hit run. And as it finishes running, it'll now let us edit our output analysis file. So at my output analysis file, if I hit agent behaviors, again, it's just going to show me every single thing that happens in all 8 times our scenario ran. I'm just going to get rid of that one because we don't need it. So I'm going to click on the X over here. And I'm going to, what I care about is the number of blue agents that are killed each scenario. So I'm going to select a filter on here, agent unit force equals add, and have it set to blue. So now we're only looking at the blue agents. So when we look at our numbers, you can see that we have 8 different runs. For the first 4, the red agents have an AK-47. For the last 4, they have an M240. And you can see that when they have the M240, we have all of our blue casualties. And when they have an AK-47, it's only partial. So I'm going to save this analysis. Close out of that. Now I'm going to create a second task group now. I'm going to call it unarmored. And I'm going to effectively do the same thing as before. However, the big difference is I'm going to use the unarmored scenario, where the soldiers are going to be moving a little bit faster. However, they are the agents are moving a little bit faster. However, they're not wearing armor. I'm also going to time of day. Look at time of day. Do late AM and quarter moon night. Close out of this. No. And I'm going to add in my analysis. I'm just going to use my same analysis file as before. I have to search for it. It's right there. Show the path. It doesn't matter. And so now I have my brass file built. And I'm also going to create a save results. Add saved results. And now I also have to set my second case matrix. Forgot to do this. Scenario length 200. I'm going to run each case twice. If I do this, it'll run each of my cases twice. Doesn't really provide that much good data, so I'm going to run it 10 times there. I'm going to change this to being 10 times as well. So I'm going to hit save, click all, and I'm going to go ahead and run it. While our brass file is running, we can now set up our DOE using our commander. So I'm going to open up RStudio, type in library, R commander, hit enter, starts loading the libraries. And I have my R commander window open. I'm going to load my R commander plugin, DOE, hit OK. It's going to ask me to restart it. I hit yes. And now I have our commander open and I can load my DOE. So design, create design, general full factorial experiment. So number of factors, I have 3 factors. And for each factor, I'm going to have 10 blocks, 10 replications. 1 block, but 10 replications. And I'm going to hit repeat only. That's important. Make sure you hit repeat only. As we move the data from iWars, from the CSV output from brass, it makes it a lot easier if everything is grouped together, and having repeat only clicked allows you to do that. All right, so now I can define my three different factors and the associated levels. So this is going to be armor, 2 levels, default, and none. Factor 2, threat, number of factors 2, do AK-47 and M240. And third, I'm going to look at time of day. So time to day, night. One thing to remember is that as you name your factors as well as your levels, make sure that you keep it as one word. When you put the spaces in there, it assumes it's a new level and it will give you errors if you don't do that properly. So next thing I'm going to do is go to export, CSV and RDA file. I'm going to change directory. I'm going to go ahead and save it over to my Lab4 folder. And I'm just going to call this Lab4 sure. Select, and I'm going to hit replace files if exists, just good measure. I'm going to hit OK. So when I go into that folder, let's see, we should have a CSV and an RDA file. We have a CSV file, we have an RDA file, so we're looking pretty good. So if I open my CSV, we can see that we have a block of 10 right here, defined as wearing no armor, AK-47 threat at night, then default armor, M240 day, and we have 8 different groupings there for a total of 80. So the next thing, I'm going to minimize that for now. And I'm going to go back into brass. And we can see that it's still running. I can expand this, see how far it's gone, and I'm halfway through the no armor cases. Fast forwarding a second, everything's now complete, and we have all of our data, all of our scenarios run, and our data analyzed. So we can look at our armored scenarios, run one, open folder, and always just select the most recent folder. Should open that CSV, and we can see that we have our data from when our soldiers are wearing armor, number blue KIA, and we have a total. We should have a total of 40 runs. So these are the 4 different cases, 10 runs apiece. Looking at blue casualties. What it doesn't give you is it doesn't give you the exact case that you're looking at for each one. So you can go back to your case matrix. And so the first 10, you can tell that you're using an AK-47 day. Next 10, AK-47 night. Then 240 day, 240 night. So what I can do now is go here. What I'm going to do is I'm going to highlight the first couple, the first row and the second row, and I'm going to paste special transpose. Expand that out. And so this is showing me what run it is, and so I can equate that to the run 1 was AK-47 day, and that's going to be the first 10. AK-47 night, that's going to be the next 10. Then M240 day. It's going to be the next 10. And M240 night. That's going to be the next 10. In every one of our scenarios, there was a KIA. If there was not a KIA, you would miss the row on here. So you have to be careful and make sure you add in a row that says 0 if that's the case. However, that's a little bit less of an issue right now. So all of these are our armored cases. So now we can put that into our CSV file. So design1.csv. I'm going to create a column called blue KIA, one word, and copy the data over. So in all of these situations, I'm wearing armor. So M240 day. I'm going to copy these 10 values over here. So going down, M240 night. So it takes a little bit of lining up and figuring out which ones go where. But M240 night, AK-47 day, AK-47 night. All right, so I now have all the data for the armored situations. Now I can go back into brass and open the CSV for my unarmored situations and do the same thing again. So because I use a similar case matrix as last time, I would expect it to be in a similar form. So I can just copy and paste from there. And everything lines up, so we're in good shape. All right, so now I'm going to copy and paste that into my design for all the cases where I'm not wearing armor. So AK-47 night. So it's going to be these 10 cases. M240 day. Going to be those 10. AK-47 day. It's going to be these 10. And M240 night. It's going to be these 10. All right, so I now have my design1 CSV file complete. I added in my response variable and added in the values that came out of our simulation. So I'm going to hit File, Save. And I'm going to close it. And also close my scenarios, all that. If I want to, I can close brass. I'm done with all that for now. The next thing I can do is I can go into Design, Import, Re-import Experiment from CSV and RDA file. So I can change my working directory. It selected it automatically. I can select my RDA file. I can select my CSV file. And I can hit OK. I always like to hit View Data Set to make sure that it imported correctly, and you can see it did. I have my response variables all defined in there, so everything's looking good. All right, it looks like now we can do a whole lot of different things, but let's just look at a quick linear model. So if we go to Fit Models, Linear Model, and so I can look at blue KIA as a function of armor plus threat plus time plus armor times threat. So look at that interaction effect. Armor times time plus threat times time plus armor times threat times time. All right. So going to see what happens. I'm going to hit OK. And when I open up RStudio again, I can look at what's significant, what's not. And you can see that the only thing that proved to be actually significant is my threat level, which makes sense. We saw that in the data where all of a sudden if we switch from the AK-47 to the M240, we start sustaining a lot more casualties. The other thing we can do, going back into our commander, is we can do our main effects and interaction plot. So if we go to Design, Analyze Design, Main Effects and Interaction Plots, I can, if I'm looking at my main effects, I can Click all three, hit OK. And this is what my main effects plot looks like, where you can see that when I go from default armor to no armor, it's pretty neutral, but when I go from the AK-47 to the M240, there's a pretty substantial change right there. Day, night, not much of a change there. I can also go to effects and interaction plots and create the interaction plots for 3 of them. Hit OK. And you can see something similar. And we saw this in the linear mall, there's not much of an interaction there. So what we can tell from this is that the variable that had the largest impact on blue KIA was the enemy weapon system, and that it was statistically significant. The time of day and the body armor level ended up not being significant from this analysis.